This is the relearning module for the radicals quiz from sections 7 and 13. And so what I'd like for you to do is to watch this remediation video, work through these examples with me. You can take whatever notes you want on this page. When you finish up with this page in the backside, which is included in the video, immediately go ahead and flip to the second sheet of paper, and that'll be your retake for the quiz. You can use all these notes on that quiz, and I'll grade it. So let's begin with transformation of functions. And we talked about transforming a radical function a little bit. We said that the general form is y equals a times the square root of, and then we showed x minus h, and then outside the radical plus k. And the h moved left or right. The k moved us up and down. And so if we're asked to write the equation of a radical function that has moved down 3, okay, we know that's going to be our k value, left by 4, okay, so we're going to subtract negative 4, and then stretched by a factor of 2, which is going to double our output. That's your a value. So let's see what happens. We're going to go y equals, inside of the radical, x. Now remember, this is kind of opposite of the way we're used to seeing it. We always think of right on the number line being positive and left being negative, but in this case we're subtracting that negative. So x plus 4 under the radical. Moving it down 3, I'm going to subtract 3 outside the radical, and then my stretch factor of 2 goes here. Okay. So we remember the main points that are on this graph of y equals square root x. We have 0, 0, we have 1, 1, we have 4, 2, and 9, 3. Okay, so that's our parent function. When we go ahead and we start to plug these values in, if I put 0 in place of x, 0 plus 4, that's 4. Square root of 4 is 2, times 2 is 4 minus 3 is going to give me 1. So when 0 goes in, I have 1. When I put 1 in, 1 plus 4 is 5. I'm going to square root of 5 and double that and subtract 3. So you can kind of see that some of these points are going to move in different ways, right? So let's maybe think a little bit, rather than putting those points in, is what if we just moved all the points that we know exist? So if I have 0, 0, it's going to move down 3, left 4, and then we're going to double that y value. So that's going to take us here. If I put 1 in, instead of being 1, 1, that point is going to move down 3, left 4, and then we double that. Okay? If I go and put 4 in, which normally would have been 4, 2, I'm going to go down 3, left 4, and then I double that value. Okay? If I put 9 in, 1, 2, 3, 4, 5, 6, 7, 8, 9, and go down 3 and left 4. Right? So you can see that this is stretched in this direction. So 3 of the points that are on our new function negative 4, 6. I have negative 3, negative 4. And I have 0, 2. And then graphing the function will look like that. Next, we're simplifying when we're dividing two complex numbers. And so we recall that when I have a complex number with including an I is the square root of negative 1. So this has a radical on my denominator. I can't leave that there. And the way we're going to eliminate that is we're going to multiply by the conjugate. So if I have 4 plus 5i, I'm going to keep those two terms, but I'm going to change the sign to negative. And I'm going to multiply in the numerator and denominator. And so now I have more or less the same as multiplying two binomials. So 7 times 4 is 28. 7 times negative 5i, negative 35i. Come back with negative 3i times 4, that's negative 12i. Negative 3i times negative 5i, that's positive 15i squared. Denominator, 4 times 4, 16. Look what happens here. 4 times negative 5i, negative 20i, and then I'm going to have a positive 20i. These two terms they're opposite, so they'll sum to 0, and then negative 25i squared. Pointing out that I is the same as the square root of negative 1. If I square I squared, that's negative 1 square root squared, which means that I squared is equal to negative 1. So I can replace these. 28 minus 47i, 15 times negative 1 is negative 15. In the denominator, 16, negative 25 times negative 1 is positive 25. So 28 minus 15, that's 13, minus 47i over 41. So now the I term in the denominator no longer exists. I've rationalized the denominator by multiplying through by the conjugate. Solving radical equations. Well, we can square both sides here. Make sure you show that that's what you did. I square a square root, I get just the radicand. So 2x plus 7 equals 4x plus 11. Now, a pretty straightforward equation. Variables on both sides, right? So 7 equals 2x plus 11. If I subtract 11 from both sides, I get negative 4 equals 2x. Divide by 2, x equals negative 2. And in neither case does that give us a negative underneath the square root sign. And in any case, we've learned how to deal with I. So we're just going to let this stand as x equals negative 2. All right, go ahead and flip the page. So we're going to rewrite this radical expression using only rational exponents. So recall that the root is going to be the denominator and the power is going to be our numerator. So I have x to the 2/3, x squared to the third, x to the second power, and then I'm taking the cube root of that. And I'm going to do the same thing with y to the 5/3. So the root is my denominator, the power is my numerator. And because these are different bases, I can't combine those in any further way. All right, simplify the expression. Write your answer as a base raised to a rational exponent. So this is important that I'm treating this as multiplying bases to a power. I multiply powers of the same base, I add the exponents. So 2/3 plus negative 1/2. Okay, so I'm adding two fractions that have unlike denominators. I need a common denominator. 4/6 minus 3/6 equals 1/6. So this equals x to the 1/6 power. So we recall that when we write that as a radical, the denominator is my root. So I have x to the 1/6 power, which I can show as the 6th root of x. In number 6, we're asked to simplify this expression, and we know from dealing with exponent rules that a product raised to a power, I can apply that power to both factors, and when I'm raising a power to a power, I multiply the exponents. Now, you wouldn't want to do this with radicals. It would be far too complicated. It's nothing that we've dealt with in class, and it's really beyond what our math abilities allow us to do in this class. I mean, if I saw a bunch of radicals here, I'd feel like you probably just did it on Mathway. So let's follow just the simplest pathway to get there, which is using our exponent rules. So I have x to the 2/5 times 4/7, and I have y to the negative 3/2 times 4/7. Okay, let's simplify these now. X to the 8/35, because 2 times 4 is 8, 5 times 7 is 35. And here, the negative 3/2, 3 times 4, 12, 2 times 7 is going to be 14. I can see here that I can go ahead and divide out a common factor of 2. So the negative 6/7. If you wanted to put that y into the denominator and write it as y to the 7/6, I'd understand that, but I think it's fine the way it is. Rationalizing the denominator. Okay, so this is a simpler example of what we did back in number 2. The rules for simplifying radicals say that I can't leave a radical in the denominator of a fraction. So I'm going to multiply the numerator and denominator by that same radical. When I do this, here's what happens. In my numerator, I have 4x to the third that's outside the radical, and then the radical of 5x. In the denominator, though, I've squared the square root of 5x. So I get just 5x. Now I can't do anything with these two because this 5x is underneath the radical sign, but I can see that I've got an x here that's going to be a common factor. So I can go ahead and divide that out. So I get 4x squared times square root of 5x over 5, and then I'm done. Okay, last one. We're going to rationalize the denominator. This is much like number 2, where I'm going to use the conjugate. X minus square root 2, I'm going to multiply by x plus square root of 2. Unlike number 7, I can't just multiply by square root of 2 here. The effect of that is I'll still have a radical in the denominator. Not going to be allowed to do that. So 5 times x plus square root 2, we can see if we need to simplify that later. In the denominator, x times x, that's x squared, x times the square root of 2, and then minus x times the square root of 2, and then square root 2 times square root 2, we get just the radicand. So 5 x plus square root 2 in the denominator, x squared minus 2. Nothing here that I can simplify, so I can let that stand as it is. So any notes that you took on this page, you can go ahead and use to help you complete the work on the next page. So go ahead and stop the video, and then turn the page, and the next 8 math exercises will be your retake on the radicals quiz.